All right, guys, I need to give you a quick bit on negative exponents, which probably seem like a crazy idea, except for some of you who discovered this accidentally today. So let me give you the idea. So let's say I started out with something like x to the third over x to the fifth, right? So today, I think you were thinking something like this pink thought, which is, okay, this is 3x's multiplied together on the top, and then on the bottom there's 5x's multiplied together. That's 4, here's 5. And then I'm going to pair these up, right? One on top, one on the bottom, and cross them out. So that's a multiplication by 1, don't need to do it. This is multiplication by 1, don't need to do it. This is multiplication by 1, don't need to do it. So what I'm left with is 2x's multiplied together, so that's an x squared, right? But it's on the bottom, so you guys were getting 1 over x squared today, right? That's like the pink thought, the like old school, hey, let's just explode and cancel. Some of you were doing something more like this blue thought, which was to say, okay, there's some x's top and bottom, I'm just going to do that subtract the exponents rule. So if I do 3 take away 5, right, x to the 3 minus 5 gives me x to the minus 2. And that doesn't make any sense, right? Because you haven't learned this. But let's just say it makes sense. Let's just define it so that we'll say, right? And this is just us making up notation, right? That's really what a lot of math is. So I'm just going to say that x to the minus 2 power is what I would have gotten with the pink thought. I'm just going to say that's 1 over x squared. Okay? So what you can think when you see one of these negative exponents is you can think this thing is on the wrong side of the fraction bar. And so, hey, I'm just going to put it on the other side, right? That's me saying, okay, this was over 1. The negative says it kind of is in a spot it doesn't naturally belong, and so I'll put it down there. Cool? That's really all there is to this. The other thought you could have is that these are like anti-x's, right? When I multiply them by real x's, they cancel out, which is, of course, exactly what happens, right? If you take an x to like, if we took x squared and multiplied by x to the minus 2, we would really be doing x times x over 1 times 1 over x times x, right? Group into onesies and cancel, get 1 out of the whole thing. Cool? Follow? So they really are a little bit like